Hey everybody, it's Mr. Bennett back with another set of notes. If you've been following along, we are in section number 2. This is the 4th chapter we've done, and we are looking at the energy types and their transformations. We've already discussed potential and kinetic energy. Okay, so we've looked at energy that's been stored up mostly by its position due to gravity, and the kinetic energy is how that energy is released in motion. And we're going to continue to talk about those a little bit, but there's a lot more different things we could. That's a terrible sentence. There's a lot of energy types that we can talk about. We're going to look at 7 of them today. But before we do that, we need to talk about this principle called the law of conservation of energy. So the law of conservation of energy. And this says that all energy in a system, and a system is something like a chemical reaction or a physics setup or your body, it's where stuff is happening, it's what we're studying, must be conserved. In other words, that means energy cannot be created and that energy cannot be destroyed. I can change it from type to type, but I cannot get rid of it entirely. It only gets changed around. So what this means is that energy can be transformed. Energy can be transformed into different types of energy, but we cannot create any new types to use. So if I need electrical energy, I have to make it from something else. I cannot just say, give me electricity. And we could harness lightning, I guess, but that would be really hard to do. And even then, lightning comes from changing mechanical energy, so it comes from friction into electrical energy. So there's, all the energy we have here is all we've got. Okay, so like I said, we've got 7 types we're going to look at. So we're going to start with mechanical, and this is the sum of potential energy, so EP, and EK in a system. So any energy stored up and any energy that is being released through motion, the sum of that is the mechanical energy. And an example of this would be like riding a bike. Okay, it's easy to see with motion. There's energy stored up in my legs, it's potential, and then as I start to pedal, right, it starts to move the bicycle. And the sum of all the potential energy in that system and the sum of all the kinetic energy in that system is the mechanical energy. And it's mostly seen through moving objects. You need stuff to see it. A second type is electrical energy, and it comes from flowing electric charges. So as those charges go from one place to another, we call that electricity. And when we have a flow of those charges, we get electrical energy. And this is what comes out of your wall outlet. It is not a battery. A battery is actually a transformer that turns one type of energy into electrical energy. So for the best example of electrical energy would be coming from a wall outlet. Something like lightning would be pure electrical energy. Chemical energy. This is energy in bonds between atoms. B/T usually means between when I'm writing, so I don't know if I've used that before. So energy in the bonds between atoms. So like my little candy bar here. This is not sponsored, but my little candy bar here. Oh, it's so good. The energy in these bonds between atoms is chemical energy. One example of chemical energy is our food. We need chemical energy to eat or to survive. Another one would be a battery. A battery contains chemicals, and they create electrical energy as they react with each other. It's a chemical reaction to start with. Thermal energy. This is the motion of atoms. One thing we're going to talk about second semester is that atoms are always moving, they're always vibrating. We can measure that motion in terms of thermal energy. There's no great example of this because thermal energy is like a byproduct of most things. So body heat is an example of thermal energy. And what we're going to find too is that mechanical systems are never 100% efficient. We're always losing energy somewhere, and honestly, most of it is in terms of thermal energy. A lot of thermal energy is wasted energy. We can't do anything with it. Nuclear energy, this is the energy in the atoms of objects. So atoms are kind of these little self-contained worlds, and they have energy there. Nuclear energy is the energy in the atom itself, not between atoms, but in the atom itself. The best place to see nuclear energy is the sun. Okay, the sun takes atoms and smashes them together, and their energies, are released in that process. We can also see them in nuclear reactors. Two more types: radiant energy. This is it's a big word, electromagnetic energy. So this is energy that is kind of just free-flowing, doesn't need anything to carry it. And the best example of radiant energy would be light. So light can travel, does not have to have air to carry it, does not have to have anything around, it just goes. Radio waves would be another form of radiant energy. And then finally, sound. This is what we call a mechanical wave. So it's energy that needs something to carry it. Like in a vacuum, there's no air. There's nothing to carry that sound. And so if you think of the movie Alien, what the tagline was, in space nobody can hear you scream, because there's no sound in space. There is nothing to carry this wave of energy that we experience as sound. So another example of a mechanical wave that would be similar to sound would be like watching a pond ripple. So the energy that stone transfers to the waves or into the water is a mechanical wave. It has to have the water to carry it. So those are the 7 types of energy. We're going to be talking about these a lot, and we can change from type to type. And there's a worksheet that pairs up with this. You can find it on the website. And as always, we have our critical thinking question down here at the bottom. Can perpetual energy, everlasting, it never runs out, ever be a reality? And then why or why not? What happens in these transformations that would either allow us to have perpetual energy or not allow us to? Anyways, you can always leave questions in the comments below. All the handouts and stuff, all these papers, you can find them on my website, which is linked right here. And thanks for watching. We'll see you next time.